Bismillahirrahmanirrahim. Dear students, grade 11th, and chapter number is 8, lecture number 53. And the new topic we are going to start according to reduced syllabus of grade 11 is ionization constant of water and pH and pOH. Ionization constant of water, then pH and pOH in the aqueous medium using the value of Kw. Now, water has a unique property, as we done in the previous conjugate acid and conjugate base and Bronsted acid and Bronsted base. Water has a unique property: donate proton as well as accept proton. It accepts proton from the acetic acid, it accepts proton from the hydrochloric acid, from the nitric acid to act as a base. But it can donate proton towards the ammonia to make acid. So it has a unique property. It has been mentioned earlier. I told you it acts as a Bronsted base as well as a Bronsted acid. So in fact, water itself undergoes ionization to a small extent because it's a very weak electrolyte. Water is a very weak electrolyte, it goes somehow ionization, small extent. So you can see the reaction here for the ionization of water, we call it self-ionization. Self-ionization of water. One water molecule acts as acid, Bronsted acid, and another water molecule acts as a Bronsted base. So this is the conjugate acid and this one is a conjugate base. So this is called self-ionization of water. One water molecule donates proton, another water molecule accepts proton. So this is according to the Bronsted caloric constant for the acids and bases. So this is the self-ionization, or we call auto-ionization. The molecule of water which acts as an acid donates proton, which acts as a base is called accepting proton. On the product side, you are seeing hydronium or hydroxynium ion is formed and hydroxyl are formed. They are conjugate acid and bases respectively. The first one in water, hydroxide as a conjugate base, and other second water molecule to give a proton, hydronium ion to give a conjugate acid. So when you write the value of K ionization constant for the acid base, we call it K, that is a concentration of hydronium ion, concentration of hydroxide ion, and the concentration of water. So you know the water is in the excess in aqueous solution. So it is a constant. It is a constant means it is in large excess. So this is a constant factor. So this one is a constant and this is the equilibrium constant. So this is called a Kw, which is written here. Concentration of the water is constant and also this is the equilibrium constant, so this is here. Both are constant. You have concentration of hydronium ion and concentration of hydroxide ion. So these two, equilibrium constant and concentration of water is constant, we call K W, which is called ionization constant for water or ionic product of water. So instead of this, we write Kw is equal to concentration of hydronium ion and concentration of hydroxide ion. So this Kw is called ionic product of water. Dear students, you can write only one water molecule, it will give hydrogen ion and hydroxide ion, because water is going to be self-ionized very little extent, small extent, so it will give a hydrogen ion and the hydroxide ion. So this equation can be written in very simple. I am writing here just like this: water, hydrogen ions in aqua solution, hydroxide ions in aqua, like this one. So then the value of Kw will be is equal to concentration of hydrogen ions and concentration of hydroxide ions. This is called Kw. So this Kw for the hydrogen ions and hydroxyl ions must be equal to 1 into 10 raised power minus 14 at 25 degree Celsius. Concentration of hydrogen and hydroxyl ion must be equal. The concentration of hydrogen ion and hydroxyl ion must be equal. So for the hydrogen ion concentration, 1 into 10 raised power minus 7, and concentration of the hydroxide ion, 1 into 10 raised power minus 7. Both are equal. So this will be a 1 into 10 raised power minus 14 at 25 degrees Celsius, which is called ionic product of water or ionization constant of the water. You can see in your book also. When you are going to add acid, when you are going to acid in a water, then hydrogen ion concentration will be greater than 1 into 10 raised power minus 7. The solution is acidic. Means 10 raised power minus 6, minus 5, minus 4, they are greater than 10 raised power minus 7. The solution will be acidic in this case. So when the hydroxide ion concentration is going to be greater, or we can say, in other words, if I am going to write here the hydrogen ion concentration, so if the hydrogen ion concentration is less than 1 into 10 raised power minus 7, the solution is basic. Less than means 10 raised power minus 8, minus 9, minus 11 up to minus 14. So this is the solution is called a basic solution. So if the hydrogen ion concentration and hydroxide ion concentration are equal to 10 minus 7, so then we can say the solution is neutral. The solution is neutral if the hydrogen ion concentration and hydroxide ion concentration are equal to 10 raised power minus 7. So when they are both equal, concentration of hydrogen ion and hydroxyl ion in the solution are equally distributed, the solution is called neutral. But if you add acid, the concentration of hydrogen ion is going to be increased. So this is going to be increased than that of the 10 raised to power minus 7, the solution is regarded as acid. And if the hydrogen ion concentration is going to be less, because you add base in it, the hydroxyl ion concentration will be more than the 10 raised to power minus 8 minus 9, the solution will be basic. And if both are equal, then we can say the concentration of the solution is equal for both. The solution is neither acid nor base. Dear students, because these concentrations are very small, 10 raised power minus 1, minus 2, minus 3, minus 4, minus 14, even 0, they are very small indeed. So that's why practically very difficult to calculate in the laboratory. For taking the acid solution, basic solution, soil, acidic, basic, whatever maybe, we are going to calculate for the analytical purpose. So the scientist Sorensen, he was a biochemist, he gave the formula to calculate to identify the acidity of the acid, means how much acid is, how much base is it strong or weak or neutral, whatever may be. We are going to calculate different samples of water, samples of like this one, other samples, food samples, there are many things, soil samples. So we want to investigate that this material, this substance, this compound, this solution is acidic or basic or neutral. So these concentrations are very, very low indeed. So this solution, he gave the formula to calculate easy. So he gave the formula for the pH and pOH. For the calculation of pH and pOH. So the formula for the pH, P small, H capital. pH will be equal to negative logarithm of base 10 hydrogen ion concentration. And pOH, P small, OH capital, negative logarithm of base 10 hydroxide ion concentration. And there is another very important, pH plus pOH is equal to 14 at 25 degree centigrade. So you must remember these formulas, you've done in the grade 10 also. pH is equal to minus log of hydrogen ion concentration and pOH is the minus log of hydroxide concentration. So normal, in general, we calculate the nature of the solution, either acidic or basic or neutral. So the pH starts from 0 to 6. pH from 0 to 6, the solution is acidic. 7, if the value of the pH is exactly 7, the solution is neutral. And if the pH from 8 to 14, the solution is basic. So this is the very simple to identify these values. They are not very small. So the pH meter or any other instrument, pH paper, we use a very light orange, yellowish orange paper, which is called pH paper. From 0 to 14 it has a pH. So when we dip the solution, it is color will be changed. Or we use a pH meter, which is a very highly sophisticated instrument. So it will measure the 0 to 14 pH. It's very simple. But these concentrations I told you 10 raised power 0 to 10 to the power minus 14, very small indeed, so very difficult to measure. So that's why this scale of pH was introduced. pH is minus log of negative logarithm of hydrogen ion concentration. It must be kept in mind that pH being a logarithm value does not have any unit. This is at 25 degree Celsius, and I told you that if the pH is 0, this means very strong solution, acidic. Very strong acidic solution, 0, 1, 2. Stronger acids from 3 to 6, they are weak acids. 6, weakest acid. 7, neutral. 8 is the weakest base. 9, 10, up from 11, 12, 13 and 14, 12, 13, 14 or 13, 14, they are very strong bases. Very, very strong bases. So generally in the laboratory here we use a pH paper. So I told you the pH paper has a very light orange yellowish color, and if there is an acid and if you are putting this pH paper, small strip of the paper, if the solution is acidic, it becomes red. So if the very strong acid is there, nitric acid, hydrochloric acid, sulfuric acid, perchloric acid, they are very strong acids. So if you put this pH paper, it will be very dark red, blood red color. The color will be blood red color. So acids, in acids pH paper is going to be red. But in the bases, if you have a sodium hydroxide solution, potassium hydroxide solution, red cleaner, very strong bases are these. So when you put the pH paper, it will be dark blue color, or we can say blackish blue color. Shows that a strong base. So there is a one here numerical to solve. The concentration of hydroxide household ammonia is 0.005. Household ammonia concentration 0.005 m. You know that this is the basic solution. The solution is a basic solution here. So if you change into power, exponential notations 1, 2, 3. This will be a 5 into 10 to the power minus 3, and this is the hydro, because this is basic. Hydroxide concentration is 5 into 10 to the power minus 3. So you have two ways to calculate. One way to calculate is using this one, POH, POH is equal to minus log of hydroxyl ion concentration, so minus log base 10, 5 into 10 to the power minus 3. So dear students, take out the logarithm of 5 by using calculator. After calculating the 5 log, so POH will be equal log of 5. Then if you take the log of 10 to the power, it is going to be only minus 3. So minus into minus plus. So suppose the value of log, you have x value, the sign is minus. So minus into minus, you will get plus. So there will be a plus 3. So you will get the value of POH. There is another also value for this Kw formula. Kw is concentration of the hydrogen ions, concentration of hydroxide ions. So Kw is 1 into 10 to the power minus 14 is equal to hydrogen ion concentration and hydroxyl ion concentration is given 5 into 10 raised power minus 3 is given for it like this one. So if you want to calculate the hydrogen ion concentration, then 1 into 10 raised power minus 14 divided by 5 into 10 raised power minus 3. So 1 over 5, then minus 14, this plus 3, minus 3 will be go to plus 3. So it means that minus 11. 1 over 5, 10 raised power minus 11 is a hydrogen ion concentration. Then you have to direct use this pH formula minus log of hydrogen ion concentration. And in this case, when you calculate the pOH, then you have to use this formula pH plus pOH is equal to 14. Take out the pH, then 14 minus the value of pH, you will get the value of the concentration of the hydrogen ion or hydroxyl ion and calculate pH and pOH both. So here is the same formula as written, second formula I told you. These are डबल से डबल टू अच्छा मैं क्लास है डबल से डबल टू क्लास में पढ़ा हूँ. So that's why you can use this formula which is given in your book. Then you have to use a pH plus pOH is equal to 14. After calculating this, the hydrogen concentration are 2 into 10 raised power minus 12. 2 into 10 raised power minus 12. So then use this formula pH is equal to minus log of hydrogen ion concentration. Then you have to calculate how much pH is that. So here the calculation is given here. So pH plus pOH is equal to 14. You have a Kw value. So then you have to calculate this one. And then a simple calculation more. These are very simple, done in the grade 10. How we calculate these pH and pOH for the given solution. Continuation of the previous topic means calculation of the Kw derivation I gave here. So sometimes they give that proof that pH plus pOH is equal to 14. Prove that pH plus pOH is equal to 14. So up to here, Kw is equal to concentration of hydrogen ions, concentration of hydroxide ions. I told you in the previous derivation. Up to here we finished. Then what you have to do, you know that Kw is equal to 1 into 10 raised power minus 14 is equal to concentration of hydrogen ion and concentration of hydroxide ion. So concentration of hydrogen ions and concentration of hydroxide ion is equal to 10 raised power minus 14. So first step that you have to take a logarithm for this. Log of 1 into 10 raised power minus 14 is equal to log of 10 raised to 1 hydrogen ion concentration and plus log of hydroxide ion concentration, like this one. So log of 10 raised power minus 14 if you calculate, then you will get the first minus 14, then log of the hydrogen ion concentration, write down log of hydrogen ion concentration then plus log of OH ion concentration. Then you have to multiply by minus on the both sides. If I multiply both, this will be a plus 14. This will be a minus log of hydrogen ion concentration. And here is a minus log of hydroxide ion concentration. So this is a 14 and minus log of hydrogen ion concentration is equal to pH. Sign is plus and minus log of hydroxide ion concentration is equal to POH. So at 25 degree Celsius, the pH plus POH is always 14. So this is a proof. This is the previous derivation I told you, this equation. Ionization constant of water, concentration of hydrogen ion and concentration of hydroxide ions. This is 1 into 10 raised to power minus 14. And this is the hydrogen ion concentration and this is the hydroxide ion concentration. Okay? Then I multiply by logarithm to the whole, both sides. This is the log of 1 into 10 raised to power minus 14. And this will be log of the hydrogen ion concentration plus log of the hydroxide ion concentration. Then this will be a minus 14 here because if you use log of this minus 14 you will get. Then multiply by the minus on the both sides. So this is the minus into minus will be a plus. This is the minus log of hydrogen ion concentration plus minus log of hydroxide ion concentration. So this is the 14. Then this in turn minus log of hydrogen ion concentration is equal to pH plus minus log of hydroxide ion concentration is equal to POH. So it is proved that pH plus POH is equal to 14 at 25 degree Celsius. So this is the 8.41 topic according to revised reduced syllabus. Ionization equation, water and calculation of pH and POH and aqueous solution using the given value of Kw value. We done this one. So we completed here. You have to calculate the activity of students. Numerical here you have what's the pH of the solution containing 1.95 grams of pure sulfuric acid. So first of all, student, you have to calculate number of moles. 1.95 gram divided by the 98 molar mass of sulfuric acid, then you will get number of moles. After calculating number of moles, sulfuric acid is dibasic acid. It gives 2 hydrogen ions. When the sulfuric acid dissociates completely into ions, it gives the 2 hydrogen ions. It displaces 2 hydrogen ions in aqueous solution. So number of moles multiplied by 2, you will get the hydrogen ion concentration. After calculating the hydrogen ion concentration, you have to use this formula and calculate the pH of the solution. Then in your reduced syllabus, the topic is 8.42. 8.42 is strong and weak acids. Strong and weak acids. Strong and weak Yesterday I told you earlier, in the previous lecture I told you that according to the Bronsted-Lowry constant for acids and bases, the acid is the donor of proton. The acid which has more ability or greater strength to donate proton is a strong acid as compared other. The species which has more tendency, high tendency to donate proton as compared other acid is called relatively more stronger acid than other. High degree. The acid which has a high degree of donation proton is called acid, and the acid which has a high degree of accepting proton is relatively strong base. Depending upon the ability of donation of proton regarded as a strong acid or weak acid, so we discussed earlier. Stronger acid donate proton the greater degree I told you as compared weak acid. The strength of acids generally expressed in the terms of Ka. The value of Ka, another one we use pKa. Both values. Mostly we use this pK value for the acids and pKb for the bases. So, dear students, the value of Ka is called ionization constant for the acid or dissociation constant for the acids. The same derivation is here, we done before, 100% same, just we are going to use here acid instead of water. So suppose this is the acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, and we are going to dissolve in water. According to the Bronsted-Lowry constant for acids and bases, acid is the donor of proton, Bronsted acid, and base is an acceptor of proton, which is called a Bronsted base, and you will get the hydronium ion positive charge, conjugate acid, and after donation of the proton, now it becomes a halide ions. In aqueous solution, this is the conjugate base. So these are the conjugate acid base pairs already we discussed in the previous lecture. So this is the reaction when the acids are going to dissolve in water according to the Bronsted-Lowry constant for acids and bases. So the K equilibrium constant is concentration of hydronium ion, concentration of halide ions in aqueous solution, concentration of the acid, and concentration of the water. Already we discussed in the previous topic that concentration of water is constant. So that's why you have to write concentration of hydronium ion, concentration of halide ions, concentration of hydrogen halide. So this K is a equilibrium constant and this is a concentration of water, both are constant, so we call Ka, which is called ionization constant for the acid. So ionization constant for the acid will be is equal to concentration of hydronium ion, concentration of halide ions divided by concentration of hydrogen halide. So this is called Ka or ionization constant for the acid. So Ka is termed as an acid dissociation constant or ionization constant for the acid or ionization dissociation constant for the acid. So it is a measure of the extent the acid is going to be ionized or dissociated. The acid which is highly dissociated or highly ionized, we call it a strong acid, and the acid which is a little dissociated or less ionized, we call it a weak acid. So Ka is independent of on the temperature. Temperature does not be affect on the value of Ka. So dear students, the value of Ka, if the value of Ka is greater, the acid is highly dissociated, so it is regarded as a strong acid. The value of Ka, if you see, there is a table 8.2. Perchloric acid has the highest value of Ka. 1 into 10 raised power 10. Power 10. Highest value of the Ka shows that perchloric acid is the strongest acid. Then less value of pKa. pKa is the inverse of Ka because the formula of the pKa is equal to minus log of Ka. pKa is equal to minus log of Ka. Nice one. If the value of Ka is large, the value of pKa is very small. So if you see the table, perchloric acid has 1 into 10 raised power 10 Ka value and minus 10 pKa value. So minus 10 pKa value shows that acid is the highly dissociated and very strong acid. Water, which has a Ka value very small, smallest, 1 into 10 raised power minus 16. Minus 16 is the value of Ka, pure water. So that's why it's a very weak indeed, and its pKa value is very high, that is a plus 16. So this highest value of pKa shows that weakest acid. Acetic acid shows 1 into 10 raised power minus 5 Ka value and 4.5 is a pKa value. Hydrochloric acid 1 into 10 raised power 7 and minus 7. Hydroiodic acid 1 into 10 minus 10 and minus 10 same. Hydrobromic acid 1 into 10 raised power minus 9 and minus 9. So dear students, this means that value of Ka is larger or value of pKa is smaller, the acid is highly dissociated and regarded as a very strong acid. Same case for the Kb and pKb. When the value of Kb is large or the pKb small, vice versa, strong base and the weak base. So dear students, we are going to finish here. This is the strong acids and strong bases. Already I told you relationship between the Ka and Kb. Also I told you that Ka is the ionization constant for the acid and Kb is the ionization constant for the base. So Kb is larger or pKb is very small, the base is a strong base. If the Ka is very large and pKa is very small, the acid is a very strong acid, vice versa. So thank you very much. We are going to finish here. The next lecture, inshallah, we start some numericals are here. Then next topic is buffer solutions. Buffer solutions and their applications. So this is also very important topic. Go through this one, solve exercise questions related to these topics. Thank you very much.